Hello and welcome. In this video, we're going to take a look at the homework section to Unit 6, Lesson 3, the basic exponent properties. Please pause and rewind the video as necessary. Part 1. Express each of the following expressions in expanded form. In other words, do all the multiplication and or division possible and combine as many exponents as possible. Let's begin. Part A, we're going to be working through many of our properties here, and in this particular one, we're going to be focused on two main properties. One, x to the m times x to the n. When the bases are the same, we add the exponent. This is the addition rule for exponents. And we have a base raised to a power, raised to another power. Well, in that instance, we multiply those exponents. So we're going to be looking at those two properties to begin with. You can see in Part A, this is following that first rule. Bases are the same. We'll go ahead and add those exponents, and x to the third times x to the 12th power is x to the 3 plus 12, or x to the 15th power. Now, when numbers are involved, take care of multiplying or dividing the numbers or reducing the numbers first. So in this case, I'm going to take the 4 times 5, and I'm just going to pull it out front, and there's my 20. Well, 20 times what? Well, I've got both x terms, so x to the, I'm going to add those exponents, to the 3 plus 5, or 20, x to the 8th power. Similarly, I'll take negative 3 times 5, and I start with negative 15. X to the 2 plus 7 times y to the 1 plus 3. So it's good to kind of show your work in this so that you don't miss. It's very, very easy to miss and make small mistakes. This one would be negative 15x to the 9th power times y to the 4th power. Letter D. Start with the negative 28. Negative 4 times negative 7 is negative 28. X to the 3 plus 4 times y to the 6th would be negative 28. X to the 7th power, y to the 6th power. Letter E. With division, very similar to the addition rule, but instead, if we're taking the same base and we're dividing by the same base, then we end up subtracting those exponents. X to the m divided by x to the n is x to the m minus n. So this becomes x to the 9 minus 3, or x to the 6th power. Again, take care of the numbers first. In this case, we're going to reduce that fraction, 5 over 15. Well, 5 goes into 5 one time. 5 goes into 15 3 times. And I'm going to take that 1/3 and I'm going to write it out in front. I'm just going to carry it out throughout the multiplication. Then I'm going to focus on the x terms. The x terms right there. I've got x to the 3rd and x to the first power. X by itself is just x to the first power. So if I focus on just the x terms, this becomes x to the 3 minus 1 times, now I'm going to focus on only the y terms. That would be times y to the 7 minus 2. Again, when I'm dividing same base, I'm subtracting the exponents. Well, this is the same as 1/3 x to the second power times y to the fifth power. Well, another way we could write that, of course, is x to the second power y to the fifth power divided by 3. Multiplying 1/3 is the same as dividing by 3. Letter G, x to the third divided by x to the 10 is x to the 3 minus 10. Well, that becomes x to the negative 7. And if we write it as a positive exponent, it's x to the 1 over x to the positive 7. Reduce the fractions first. 5 goes into 10 and 25. 5 goes into 10 2 times. 5 goes into 25 5 times. So I'm going to take that. I'm going to carry that 2/5 out in front of the multiplication. Now I'm going to focus on the x terms. I've got x to the 4 on top and x to the 8 on bottom. This becomes x to the 4 minus 8 as I will subtract the exponents. Times whatever's left. In this case, y to the third. Cleaning this up a minute, we have 2/5 times x to the negative 4, 4 minus 8 is negative 4, times y to the third. Well, this is the same thing as 2 to the 2/5 times, now I'm going to turn this into a positive exponent, so that's 1 over x to the fourth power times y to the third power, which is really y to the third power over 1. So if I clean all this up, I get 2y to the third power over 5x to the fourth power. Raising a power to a power, we have x to the 5 times 8, or x to the 40th power. Letter J, we have 10 to the 3, we have 10 to the 0 power. Notice we have 10x cubed, all raised to the 0 power. So this is 10 to the 0 power times x cubed raised to the 0 power. Well, that's the same thing as 1 times an x cubed raised to the 0 power is also 1. In other words, we just get 1. Letter K, we're going to apply this cube to the negative 4 and the x to the fifth. So this is negative 4 to the third power times x to the fifth to the third power. Well, negative 4 to the third power is negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4 times negative 4. Well, 4 times 4 times 4 is 64. So negative 4 times negative 4 is positive 16. Positive 16 times negative 4 would be negative 64. X to the, multiply the exponents, 15th power. X to the negative 2 to the fourth power would be x to the negative 8 power, which would be 1 over x to the positive 8 power. Number 2, which of the following is not equal to 2 to the negative 2 power? Do not use a calculator to do this problem. Well, 2 to the negative 2 is the same as 1 over 2 to the positive 2. So remember, we want to which is not. So, well, that's true right here. So this one's out. Well, that's also the same as 1 over 4, because 2 squared is 4. So, well, 1 over 4, that is, so that's out. 1 over 4 is the same as 0.25, so that's out, making this the only one that's not equal to 2 to the negative second power. Number 3, if the expression 1 over 2x was placed in the form a times x to the b power, where a and b are real numbers, then which of the following is equal to a plus b? Show how you arrived at your answer. All right, so first things first. Let's take this expression and rewrite it as a times x to some exponent. Notice x is in the bottom, so we're going to have to rewrite this. Now, 1 over 2x to the first power. I'm going to take the 1 over 2 and separate it, times 1 over x to the first power is the same as 1/2 times x to the negative 1 power. Now, if we follow this, that would make this a, and that would make this b. A x to the b power. So a is clearly 1/2, and b is clearly negative 1. Now the question wants to know, what is a plus b? So we got to add those together. One half plus negative 1 is the same as 1/2 plus negative 2 over 2. Just rewriting 1 as a fraction so that I can add it to this fraction. And 1 plus a negative was really minus, so 1/2 minus 2 over 2 is the same as negative 1/2. Part 4. If f of x is equal to 5x to the 0 power plus 4x to the negative 3 power, then evaluate f at a. What does this function notation mean? It means plug in a for all x. So every time you see an x, you're going to replace it with an a. So here's our function. We're going to evaluate with a. So it's 5a to the 0 power plus 4 times a to the negative 3rd power. Well, let's evaluate this part. A to the 0 power is 1. So this begins with 5 times 1 plus 4. A to the negative 3 is the same as 1 over a to the positive 3. So this is 5 plus, we can multiply that together because that's 4 over 1, 4 over a to the positive 3, which would be 2. Number 5, which of the following is equivalent to 4x to the 8th power cubed over 6 times x to the 5th power squared, for all x that are not equal to 0, of course, because we can't have 0 in the denominator. That would be bad. Show the manipulations that lead to your final answer. So basically, we got to simplify this, which we're going to start by applying the cube to everything here and applying the square to everything here. So on the top, we have 4 cubed times 8x to the 8th power cubed, and that's over 6 squared times x to the 5th power squared. So we begin by applying this cube and the square to everything, top and bottom. Well, 4 cubed is 4 times 4 times 4, or 64. A power to a power, we multiply, so that's x to the 24. over 6 squared, which is 36, x, the power to a power, we multiply, so 5 times 2 is 10. Now, let's go ahead and simplify this fraction first. Let's deal with that. The largest integer that seems to go into both 64 and 36 is the number 4. 4 goes into 64 16 times. So 16 times 4 is 64, and 4 goes into 36 9 times. So let's take that fraction and put it out front, 16 ninths times, and then we're going to deal with the same base right here. Remember, same base dividing same base, we subtract the exponent. So times x to the 24 minus 10. Well, that's 16 ninths times x to the 14th power. Part 6. It is helpful to be able to think about very large numbers in terms of powers of 10. You should be familiar with many of these terms, but have you thought about how many tens are multiplying each other? Here are some numbers to think about and examples of things that would be counted in these quantities. You want to fill out the proper power of 10. The first one is done for you. So in other words, we're going to complete this part of the table, this part of the table, this part of the table, this part of the table. Well, okay, the first one is done for us. We have 1,000 times 1,000, which is a million, right? 1,000 times 1,000. And we can see that's 10 to the third times 10 to the third. What do? We add the exponents, and we get 10 to the 6th. We're using our exponent rules. Let's do the next one. A billion is just 1,000 million. 1,000 times a million. Add those exponents, and it's 10 to the 3 plus 6, or 10 to the 9th power. A trillion is a million squared. Well, a power to a power, we multiply, so this becomes 10 to the 12th power. A quadrillion is 1,000 times a trillion. Well, a trillion itself, we already saw, was 10 to the 12th power. 1,000 we saw was 10 to the 3rd power. So if we multiply those, 10 to the 3rd times 10 to the 12 is 10 to the 15th power. And lastly, a quintillion is a billion squared. So a billion is 10 to the 9th power. And let's square that. Well, that would be 10 to the 18th power. Part 7. The functions f of x equal to 2 to the x power, that would be this function right here, and g of x equal to 8 times 2 to the x power, that's this function here, are both graphed. The graph of g is certainly a vertical stretch. In other words, it certainly looks like a taller version of this graph. And it is. But it's also a shift of f 3 units to the left. Can you explain why this using an exponent law? In other words, look at these points, ladies and gentlemen. This data point is just shifted over 3 units to the left, as is this one, as is this one, as is this one, as is this one. In other words, this entire graph is really just shifted 3 units to the left. Now, let's explain this using exponent properties. Start with the fact that g of x is equal to 8 times 2 to the x power. Now recall, two to the 3rd power equals 8. So you could rewrite this, ladies and gentlemen, as 2 to the third power, replace 8 with 2 to the third power, times 2 to the x power, right? That's the same thing as 2 to the third power times 2 to the x power. And what do we do when we are multiplying same base? We add the exponents. So this becomes 2 to the 3 plus x, which easier if we write it as 2 to the x plus 3. So 2 to the x power, or 2 to the x plus 3, that is a horizontal shift. Horizontal shift, 3 units left. Okay, why is it 3 units left? Well, if I were to rewrite this, x minus 3, x plus 3 is really x minus a minus 3. You're going 3 units in the negative direction, that's why. We just typically write it as x plus 3. Again, pause and rewind the video as necessary, and thank you.